All right, so today we're going to be talking about open authentication or OAuth vulnerabilities. So let's go ahead and jump into it. Let's talk about first what OAuth is and how you've probably already interacted to it. So when you sign into a website, sometimes you'll see options like this that let you sign in with another account. And this is usually done through the Open Authentication 2.0 framework. And the idea behind it is to, instead of having every single person who provides a web service needing to have you make an account, you could use some other provider to authenticate yourself to some kind of resource or some kind of, or, at least say that you are who you say you are by using one of these OAuth providers. And that's basically the gist of it. If you've used any of these or made any accounts like this, you've kind of got an idea of how it works on the surface, right? You go to a website, sign in with Google, you enter your Google credentials, and all of a sudden you've got kind of an account on this site, even though it doesn't use an external login or anything like that. So let's talk a little bit more about how it works. This is a high level kind of depiction, and we'll talk about a low level one in the next slide here. But how it works, first we'll kind of cover the terminology. So the client here, or a client application, is the website or app that wants access to some user data. If it's just using a base implementation, it's probably going to just ask for like your email and maybe like your name, or if it's like a weather application, it might ask for your location data, stuff like that. It just depends on how the request is made. The resource owner is typically the user, or whoever owns the data, which is you. And then the authorization server, this is what we would call like the OAuth service provider. So in this case, it's Google, if you could tell where I got this image. But in this case, it's Google. So they have an authorization server and a resource server. Typically, the client will ask the resource owner if they, should be allowed to use that OAuth provider. Then, they say, yeah, I would like you to do that. And this doesn't go straight back to the client necessarily. It kind of passes through the OAuth provider. But the client will then ask for that, permission. Authorization server verifies it, gives a token, and then the client application can use that token to access some kind of protected data on the resource server. Makes sense, right? Gives the clients access to your data in a somewhat safe way. The way that it does this, though, is with something called grant types. So the two most common of these are the implicit grant type and the access code or authorization code grant type. And this is moreover just how the client application is able to get access to that data. So which steps are needed for the application to be authenticated. So typically that would happen between these couple steps here, between 2 and 3 and kind of 4, is when you would see the implementation of this and how it works. And the scope is briefly described, or if I can describe a scope quickly, it's basically just for a given grant type, like an application code or an authorization code or implicit. It's just saying what, how do I say it? The scopes that you can request are unique to each OAuth service. So like these URIs are going to be different, but these are just the scope determines what resource you're trying to access as the client application. So in this case, if the application offers some kind of contact syncing, or like let's say you sign up for Twitter and it wants to link you with some people in your phone's contact list, or your like email contacts from Google, it might use the contacts data on the resource server to help you connect with other people who've made accounts using open authentication, or who have synced that data, something like that. Let's talk about how the authorization code setup kind of works. So something that I want to cover first before I talk about this diagram step by step is that once this like code token exchange here is completed, so once the code and token are exchanged in steps 5 and 6, all communications between the client application and the OAuth service, like the authorization server and the resource server, should not really be visible to the end user. It should be done on a secure like backend channel. And that, typically just helps you with your like safety precautions that you're taking. And this is where a client secret is generated that the client application then uses for those things. And that's why we'll see it here as we go through it. But now that I've kind of clarified that, let's talk about it. So First, the user will access the application. Client application will try to use OAuth, so it requests authorization. The authorization server asks if the user says that's cool. They say it's cool. The authorization server then issues an authorization code. And then the client application asks for a token. The authorization server makes sure that whatever that request is legit and what they agreed upon using the authorization code and through the consent ask. It then returns a token that the client application can use to request data using an API from the resource server. And then the resource server will return that data if the API token is still valid. So what that looks like on the right here is the client application will ask the OAuth server, hey, can I get authorized? Here's my client ID. Here's where I want you to send the next thing, which is the authorization code. So send it to client app/callback. And the response type or the OAuth flow or grant type that we want to use is code, which is like a authorization code. The scope, which is the data that I want, is just a OpenID profile. So those two things, depending on how the API is set up. And then the state, which is pretty important secure-wise, because if this isn't here, it could actually cause some like cross-site request forgery issues. The state parameter is used to map an authorization request from the client application to a specific user session. And the reason that's important is because if if your client application isn't configured to use the state parameter, because it's not mandatory, you can choose not to use it. But if you don't use this state parameter, the issue you run into is that if you're not mapping this authorization request to a specific user, then we might be able to feed a link to a victim user that gets them to, authorize on our behalf, and we might be authorizing more data to be shared, or we might be, serving that victim user a link that actually authorizes like our Gmail account to link to their, like Joe's Crab Shack account or something, right? So that's kind of the example of an attack vector you could use just by looking at this. Also, you might be thinking, the redirect URI is kind of juicy because, well, if we can just stop this request from going through and change the redirect URI to our server, then wouldn't we get this callback code that's being sent? And the answer is yes. So you should be sanitizing those, and we'll cover it briefly, and I'll kind of show you what that looks like. But once the client application requests authorization like this, and it's sending that to the auth server, the authorization server for the OAuth service provider will then reply with this authorization code. And then it also has the state token there. Again, not required, but is important. Sends that over to the client application. Then the client application will then ask for a token. So number 6 here. And it'll again say, here's my client ID, and this is where the secret comes in. So what we can't see is the OAuth service provider through some backend channel sends the client application this secret value to have here as part of this request. And once that that's included, the redirect URI is stated, the grant type, authorization code, and the code that it just gave in the callback here is provided. And so by requesting a token, and because the client application submits the secret that was established on the backend channel once the application was registered, then it says, okay, everything looks good. Here is your access token. So it gives you, your token, how to use it. So the token type, the expiration time, and then the scope that's associated with that token, which we declared up here, OpenID and profile. Whoops. So then what will happen is the client application will then send a request to, maybe for user information to the resource server. So this is number 9. Now that they have this API token that they can use. Pretty straightforward. Makes sense, right? Like, it's a few steps. The only, confusing thing might be that backend channel of communication. So just keep that in mind. The implicit grant type is less secure, and typically you should only use this on like a simple application that only has front end stuff and really doesn't have like any super sensitive data that's accessible to it. And the reason for that is because this doesn't use that backend communication channel of swapping the secret back and forth. So you don't have that added layer of security of like the client application registration mattering as much. And then also it doesn't use the whole it doesn't send a code and then the access token. It will typically just reply straight away with the access token if it knows that your client ID has already been verified. So that request might look like, okay, callback, here's the access token, and obviously this is after a couple things. But this is the OAuth server sending the client application, just here's the access token, it's a bearer type, it expires in this amount of seconds, the scope is OpenID and profile, and here's the state that maps that back to the user session. So whereas typically, like if we go back one, you'll see that first they exchange a code, and then this data would be sent in another separate request. But in this, there is no code being exchanged, it's just this one thing, and there's no backend communication. The reason that could be dangerous, there's a couple different reasons, but we'll cover those in a second. If you're identifying these, typically, if you just look at your HTTP traffic while you're using an OAuth enabled endpoint, you'll see like some pretty recognizable like OAuth endpoint names. But there's also like word lists you could use if the functionality isn't readily available to you, which I think we'll cover in our lab, at least, we'll talk about it. And then as far as exploiting it goes, you got to keep in mind there's two different places that vulnerabilities for this can pop up. One will be the OAuth service provider, and then the other will be the client application and how they implement the OAuth functionality and how they're sending those requests and things like that. So, for example, as an OAuth service provider, you should require that the state parameter be used. And as a client application owner, you should be, using the state parameter even though it's not required. There's a few different things you can, exploit, and obviously this is just scratching the surface here, things you might see most common, but of course there's more creative and elegant ways of exploiting these kind of vulnerabilities. So flawed use of implicit grant types. This might be if the grant type just allows, is just set up poorly. Maybe they don't use the state token. And if you don't use state, that would kind of link into cross-site request forgery protections, because again, if you're not mapping a user session back to an authorization request, you're going to have some problems. Authorization code leakage. If you allow me, and that kind of ties in with redirect URI validation. If you don't verify the redirect URI, I might be able to get this auth code to be sent to a different URI than the one is intended by the client application, like my evil, web server. Flawed scope validation would just be if I'm allowed to add additional scope parameters to a request, I might be able to extend how much the resource server is allowed to give to the client application. So if you only want the application to access, your contacts list, but I'm able to add another scope parameter and say access contacts list, password vault, et cetera, then you might have some more, issues. And then unprotected client registration is kind of a big one. If I'm able to see your open authentication implementation to such an extent that I can register my own client application and then trick a victim into using my malicious client to authenticate using OAuth, that would be a pretty big deal. So that's another thing to keep in mind. Let's go ahead and jump through at least one of these examples in our lab, which is a hack the box machine called Oouch, and then we'll come back here and talk about prevention. All right, so we're here in the hack the box machine called Oouch. You can see that gives us this. I don't know if that's because we already added it to our hosts file or if the IP hasn't changed, but if you just run a port scan, or not a port scan, whoops, a directory scan on here, and here's the command if you want to do it yourself, you can see that in addition to the login and register pages, we've got logout contact, interestingly, an OAuth endpoint, which will be useful. So we'll go ahead and start by just making an account. So let's just say Gabe. That was sign in. We need to register. We'll just say 1. I don't know if it'll let me use bad passwords. Okay, so now that we're here, we can access some of these different things. You'll see like there's a documents page, there's about, there's a contact page, which we will have to use. We can we can send information to, like an admin to view it. Let's see, welcome, we get the idea. And then here you can see there's like connected accounts. Now there's no like easily viewable functionality on here. I wonder, actually, I didn't check this, but if we inspect the page, okay, so it doesn't get that in some way we can control. So if we just go to the OAuth endpoint, you'll see we've got, okay, consumer.ouch.htb. Now I don't think, okay, so it looks like, let me do my host file. Okay, so this hasn't changed. So it kind of gets rid of some of the discovery process of this, but there are two different domains. One of them is on 5,000, which is this web application we're looking at. The other one is on 8,000, which is this, which is the authentication provider, or the OAuth provider, whatever you want to call it. So this prompts us to sign in. It's at this point that I'm going to turn on my proxy so that we can see what the like connection and sign-in processes look like. So again, we see there's an OAuth connect, or login next equals that. Okay, CSRF token, submit sign-in, and then you can see this OAuth connect request being made again. This is being made to the consumer endpoint, and now you can see what we just talked about. Here's the consumer's client ID. They're asking for an authorization code. Here's the redirect URI, and the scope is just to be able to read some kind of data. So it might be full permissions, that might be small, it just depends on the implementation. But it's sending this to that service on 8,000, which is probably an OAuth endpoint. We can then see that it redirects us to log in on this authorization server, or the OAuth provider, which we haven't made an account on here yet, so I think we'll actually duplicate this. And I think there's a register endpoint, maybe. What if we just go to the main page? Yeah, here we go. So we can make an open authentication account. So let's do that. Let's just call this Gabe OAuth. Gabe CTF. And then you can use these other steps for later in the machine, but for now we'll just keep doing this. I don't know if it'll let us use that password. Yeah, it's going to throw a fit. Okay, let me do. Let's try that. Okay, that seemed to work. So we do Gabe. And I think we'll actually do it from this one, but it should be the same. Gabe. Then it redirects us back to this home page. So we authenticated. We can use the authorization server. There's these two authorize and token endpoints. Now, I wonder, did that finish connecting our accounts, or do we need to try again? I think we have to try again here. So let's go ahead and kick off the connection again. So this is just us connecting our OAuth account with whatever the other one is. You can see the same client ID, code, etc. And now that we have a session or something, it's asking us to authorize. Cool. So this is going to authorization. It's asking for it's saying, when you give us that code, send it to this connect token page. And then you can see here's the code that's being transmitted from, so this is coming from authorization to the consumer page. And something to pick up on is, notice how there's no state parameter being used here. So it's not mapping this to my user session. Yes, there is a, what looks like a JWT cookie here. But, if state isn't being passed to the, isn't being passed to the authorization page, then this consumer application might not actually be doing any kind of calculation on which user is actually clicking this link and authorizing a connection. So then it redirects us to our profile, and it looks like it authenticated us correctly, or at least it linked these accounts correctly. Let's go ahead and look back at our HTTP history. And okay, I've got this sorted. So you can see we go to profile, we click on connect, it redirects us to this page with the client ID, response type. So it doesn't look like we're going to be able to manipulate these things because it's expecting those, but it doesn't seem like it cares about the state at any point. And I can even, goodness if I can spell, look for it in some of these. It looks like state is, it's a hidden parameter that you can use here, like ID underscore state, but it doesn't seem like the OAuth service provider is requiring that we use state. And what we could do is, we already know that we can, through the, what's it called? Through contact, this endpoint, we already know that we can get somebody else's, we can send somebody a link that they might click on. So it might be feasible to assume that, okay, if we can try to connect our account and then drop this code request so that it doesn't get sent, if somebody else clicks on this link that authorizes the code, then, because they're not using that state parameter, it won't matter if they're using our account, or it doesn't matter if they're trying to connect it to their account or not. It's just going to, the client application is just going to see, oh, this user just clicked on this link to authorize and this code is still valid. It hasn't been used to connect to account. So, when it gets sent, the OAuth application says, yeah, you're permitted to link those accounts, but the client application doesn't realize that there's a different user who's just clicked on it. And so it connects the account without checking who actually clicked that link. So I suppose you could call it, this is kind of like cross-site request forgery because we need interaction from the user. So that being said, let's go ahead and I'll kind of show you what that looks like. So I don't think we need to unlink our accounts for this. I might be wrong, but let's just give it a go. So first, we're just going to go back to that like OAuth endpoint. Maybe I need to get rid of that. Oh, that's going to kick off a Google search. Why is it being tricky? Here we go. Let's go back to this connect page. Authorize, token, client. Okay. So now when we click on authorize, it's going to try to do that. This is what we need to stop. So we can just send this to the repeater so we have it, and then we'll drop this request. Should get an error. That's all good. And then what I'm going to do is just, I think I should have it in my browser history, but if we go just back to like our login page here, we'll go to contact. You can see customer contact support, and if you have feedback, don't hesitate to contact. This is more of a CTF thing. If it was a real environment, you would probably be a little bit smarter about getting a user to click on this. But, instead ask our system administrator something, please do not submit security issues using this form, which I don't know why you wouldn't, whatever. Anyway, we can submit something. I think we can just do like test. Yeah, you can see I've got it right here. We'll just have to swap out this authorization code, but let me just swap that out for the one that we intercepted. We'll try that. And what this is doing is it's just submitting, test, the word test, and then it's linking this, OAuth connection with a valid code to this hyperlink. So we assume that the user sees this and navigates to the link. And if that is the case, then it should link our OAuth account with theirs. And then when we log in to the OAuth provider, we should see that we have access to their account. So we'll go ahead and send that through. And I don't think we'll have to wait terribly long. I'm pretty sure it replies fairly quickly. So like if we go back to our profile, I'll just refresh it a couple times. Or maybe what we'll do is, where's that OAuth page here? We go ahead and duplicate this tab. Refresh, still taking a while, but ugh. Here we go. So we'll wait and see if it unlinks. Oh, that's weird. Okay, so you can see our account is no longer connected. So maybe there's some logic built in for the OAuth server or the client application that says one account cannot have two OAuth accounts linked to it. That would make sense. Let's try and log in with that. Once your account is connected, we should be able to use the authorization server. So we can try to do the OAuth login here. Okay, there we go. So once we finally, after what felt like forever of just messing around and doing the same thing over and over again, we eventually got access to the QTC user's account. So in this case, the big issue really is that when they are using well, I guess not really just like one thing, but whenever they go through this authorization process of linking these accounts together, I guess this isn't really the initial one, but whenever they go through this process of linking the accounts, they don't use that state parameter that links a user session to a actual session. So when we click on the link, or when we try to log in with OAuth, it asks if we want to authorize, and if we click yes, then it connects us to this account. So there's your issue. That's all we've got. So we'll go ahead and jump into prevention. All right. As far as prevention goes, there's a few different steps depending on what role you play in this process. So if you're one of the service providers for OAuth, you want to make sure that your clients are whitelisting redirect URI parameters, but they also need to be employing like good input sanitization. You want to also be enforcing the use of a state parameter and bind that to a user session so that cross-site request forgery attacks are a lot more difficult to pull off. You also want to verify that client IDs that make requests are using access tokens so that each client is using their own specific token instead of maybe using the same one for every single data request. If you are the client application, you'd want to use the state parameter, even if it's not mandatory. It's just a better protection to have. Send the redirect URI parameters to both the authorization and token endpoints. Make sure that you are, trying to keep the client secret value private by using, countermeasures for code interception or leakage. So make sure that you're using that backend channel correctly. And then be careful when you're using authorization codes because they could be leaked through dynamic content like images that are being pulled from other sites or scripts. And if you don't pick up on a DOM sync or HTML, read write, then you might have issues related to this. So as long as you keep those in mind, you should be set. But until next time, have a good one.